What's going on here? Every time I throw the ball straight, it seems to bend to the side. No matter what I throw, no matter how straight I throw it, the ball seems to be curving. Maybe it has something to do with this. That whole time I was spinning, which is why it looks like I'm about to puke. That curve is created by the Coriolis effect. You may have heard that it makes water in the bathtub spiral down the drain a certain way, or that it determines the way a toilet flushes. That's actually wrong. Those are not caused by the Coriolis effect. But the Coriolis effect is what makes hurricanes spin, and it's the reason why Jupiter's Great Red Spot is spinning the way that it is. So what is the Coriolis effect? Well, it's what happens when objects moving in a straight line appear to curve because you are rotating, and it affects all kinds of things. It bends the paths of missiles and sniper shots. But how does it work, and how does it create hurricanes? Right now, it seems like the ball's curving, but let's take a look at what's really happening. My friends and I put together this little experiment using a sort of spinning seesaw. Here, the camera's standing still. It's just hanging from the ceiling. And watch what happens. From the moment the ball leaves my hand, it's just going straight. Let's watch that again, frame by frame. Keep your eye on the ball. You can see it travels in a perfectly straight line. But what if you're spinning with the seesaw? Look at what happens when you rotate the footage so the seesaw stays sideways and everything moves around it. Now let's follow the path of the ball again, but from this new perspective. The trajectory looks completely different. Now let's watch this one frame by frame. From this rotating perspective, it totally looks like the ball is curving. That's crazy because you already saw that exact same throw. Watch it again on the left. The ball is going straight, but on the right, when you're rotating with the seesaw, the ball really looks like it's curving. You might be thinking, why should I care? I don't spend a lot of time on a spinning seesaw or on a merry-go-round, but you kind of are on a merry-go-round. The Earth is constantly spinning. Have you ever seen someone in a movie making fine adjustments on their gun? Well, one effect they're correcting for is the Coriolis effect. The longest sniper shot, which was over 3,000 yards, would have had to correct for a 1-foot deviation due to the Coriolis effect. So how does the Coriolis effect create hurricanes? Hurricanes form when air rushes from all directions into a low pressure region. So imagine there's a low pressure region between the two of us. Air is going to rush toward the center. Let's see what that looks like from space, from our camera that's hanging from the ceiling. It's not spinning, so the air, or in this case the balls, are clearly going in a straight line. But if you're rotating with the Earth, or with the seesaw, you'll see the air bend to the right. In the northern hemisphere, this creates hurricanes with counterclockwise spirals. In the southern hemisphere, it does the opposite. It creates hurricanes with clockwise spirals. This storm on Jupiter, which is actually bigger than the Earth itself, has been spinning for at least 200 years, largely due to the Coriolis effect. So when you're in a rotating frame, the Coriolis effect seems to exert a very real force on objects. But there is no force. What you observe is just a result of your perspective. And you might be wondering, if this is simply a product of your frame of reference, then could other forces like gravity or electromagnetism also just be products of your frame of reference, of where we live in the universe or in the multiverse? For more on that, check out our video, Do We Live in the Multiverse? There are talking fish. And if you want to find out when new episodes come, click subscribe.